Good morning and welcome to Dr. Logic Awkwardly Does Logic, this time in her emergency duvet because her office is cold. Last video, I worked you through an example of the shortened truth table method and showed how you could kind of reason through filling out a line in a truth table in a more efficient way to determine whether something is a tautology or not. I also promised that next time, i.e. now, I would talk you through how to write out an answer that doesn't just kind of result in a completed line of a truth table where you can't necessarily determine how it was that we got to that particular answer. So this is going to just be the same method, but much more verbose. So we got to have a whiteboard because we got to have some place to write things down. So here we go. And the example that I'm going to look at today is this sentence. Oops, let me get my drawing. There we go. We want to know, is not P or Q and R implies Q. So does that imply P or not Q? So is that entire sentence a tautology? So remember that the way to answer this question is to turn it around and ask another question, namely, is it possible to make this formula false? So let's just go ahead and suppose that we can. Suppose we can make this well-formed formula false. Then what do we know? We know first that the value of the antecedent, so not P or Q and R implies Q, has to be true. And the second thing that we know is that the value of the consequent, P or Q, is false. Now, the reason I've labeled these 1 and 2 is that we can then work out the consequences of each of these. So, for instance, by 2, we know there's only one way for a disjunction to be false, and that's if both of the disjuncts are false. So we know that the value of P is false and that the value of Q is false. Now, something that's useful when you're doing these kind of written out explanations, or even when you're doing the truth table version, is as soon as you have a truth assignment for an atom, just kind of write it off to the side so that you know that everywhere P has to be false, and also everywhere Q has to be false. And right now, we still don't yet know whether R can be true or false, or if it doesn't make a difference. Now, we have, so once you get to the level of atoms, you can't do any more. So let's go back to the other complex formula we have, which is number 1. So by 1, we know that if a negation is true, the formula without the negation is false. So that means that, oops, it's got to be P or Q, and R implies Q. The truth value of that is false. Now, there are 3 different ways that a conjunction can be false. So what we can say is there are now 3 possibilities. So let's do 6A. The first one is that the value of P or Q equals false. The second one, call that 6B, is that the value of R implies Q is false. And 6C is just both 6A and 6B. So we need to have at least one of these needs to work. At least one has to work. And in fact, if you look at 6A, we already know that P or Q is false because that was, oh, wait, I just realized I did a cardinal logician's error, which is I dropped a negation. We've got a not up here. Okay, let's go through and see what we need to change. So first of all, we have this not here. So we need to have that the value of P or not Q needs to be false. So by 2, we know that, okay, the value of P is still false, but then we need that the value of not Q is false. So we don't yet know that what the truth value of Q is. We will in just a moment, but let's continue rewriting. Okay, so everything else is good, but I'm going to erase this in fact. And now we can actually go in and say, whoops, we've also got, so by 4, we know, and I'm just gonna say for A, that the value of Q equals true, because it's not Q, that's false. So we need at least one of 6A, 6B, and 6C to work. Well, because of this, because we already know that the value of Q is true, we know it's not 6A, because the value of P or Q is in fact true because the value of Q is true. Also, because of this, we know it's not going to be 6B because Q is the consequence of the conditional, and anytime you have a conditional with the true consequent, you have a true conditional. And so if it can't, if it's not 6A and it's not 6B, it's also not both of them together. So we know that it's also not 6C. These are the only possibilities. Given that the value of Q is true, there is no way to make 5 false. So overall, there is no truth value assignment. Remember, that's what TVA stands for. That makes our original formula, let's call it phi. There is no truth value assignment that makes 5 false. Therefore, this is in fact a tautology. There you have it. Slightly messy and with a mistake in the middle, but hey, it's a good object lesson. Always pay attention to your negations when you're writing a formula down to make sure that you don't miss one, because if you miss one, then everything is going to end up bad. All right. I guess that is good enough for now. I've got a couple more things I want to say about semantics, probably just maybe 1 or 2 videos worth, and then we get to start talking about proof theory. Proof theory is daunting and thoroughly satisfying, so I can't wait to show it to you guys. Take care and see you next time. Cheers.